Hello everyone. In this video, I will show you how to use ShinyCNV to view and annotate copy number variations. First, you need to install R and RStudio. You can find them either by Google or the links provided here. After installation, you can open RStudio and it looks like this. Next, you need to download the ShinyCNV from GitHub. Here is the link. And you can download it from here. The zipped file is pretty big because 11 samples snip data from 6 cases is included as the example dataset. Here they are. Then unzip the ShinyCNV file to any folder you like. Here, we just put it on desktop. Then open RStudio. Switch the directory to the unzipped folder. Then open config.r file to see how ShinyCNV is configured. This command line will check the dependent R packages and install them if they are missing. Make sure the internet connection is available if the installation is required. These two lines indicate where the snip data is stored and what the file extension is. ShinyCNV supports plain text and gzipped files. As you could see here, the files should be in folder snip data with extension .txt.gz. Then let's move on to the app. You can open either UI.R or server.R to run this app. Click Run App button here. Now you should see this panel coming up. If some dependent R packages are missing, the installation process may take a few seconds or minutes. Then you can select the file containing the reported CNV regions. Here are two example files. This 1S file includes CNV result from one paired case control samples, and ShinyCNV will take around 1 GB memory to run it, while the other one includes all the 6 cases, which will use around 3.5 GB memory. So keep in mind, the more samples you load, the more memory will be consumed. Here, we will use this one. Before moving on with the app, let's take a look at these two input files. Here is an opened snip data file, which includes more than 2.5 million SNPs from chromosome 1 to Y. In the CNV region file, you could see all the columns described in the GitHub tutorial. The SNP file name is case ID or control ID, plus the file extension defined in the config.r script. That's how this app figures out the link between sample ID and snip data. After importing the CNV regions, you can see part of the regional table is shown in this CNV table panel. Under the column Note, all the CNVs are marked as false and waiting for manual review. In this panel, you could see CNVs from pages. Select a CNV. Move to its previous or next one. You can also add a new CNV after the selected one. Mark the CNV as germline, covered by other bigger CNV regions, false positive, or true CNV. Also, you can change the chromosome, the copy number, the normal sample contamination rate for the selected CNV. And of course, you can delete the CNV. Be cautious when you want to clear the SNP data, because loading the SNP data usually takes a long time, as I'm showing you by clicking Reading in SNP data to start the data loading. After the SNP data is loaded, you can select any CNV region to check if the CNV is reliable or the boundaries are accurate in BAF-LR panel. As you can see here, the boundaries are marked by two vertical red lines. The smoothed LR lines are also shown in red. With the visualized LR and BAF data for matched case and control samples, you can easily tell if the CNV is real or not. And then you can mark them as germline, covered, false positive, or true. Anytime you modify the CNV table, a backup file named cnv.back will be updated simultaneously. For example, this CNV shows distinct BAF between case and control samples, and also the evidence for LR is convincing between case and control, so it should be annotated as a true CNV. All the RAF6 genes are marked as the bars at the bottom, and the red ones are cancer genes according to Cosmic database. To get the information of the genes, you just need to click them. For example, this one is ETV6 gene. For the CNVs with inaccurate breakpoints, ShinyCNV can help to pick the correct boundaries intuitively. For example, this one. When you notice the end position seems incorrect, and more importantly, there is a cancer gene around the breakpoint, you can zoom in by mouse swipe to check if the breakpoint is correct. Here you could see the cancer gene should be affected by this CNV. Then you could adjust the breakpoint by clicking the spot which should be the boundary. And the coordinate of the SNP nearest to the clicked spot will be shown in the position box. And then you could update this position to CNV table by clicking Set End. Click that CNV again, and you will see the update is reflected in the BAF-LR panel. If you want to check a known region of a specific chromosome, you can directly input the position into POS input box and update them into the CNV table. And also there is a situation that you may want to annotate the CNV on whole chromosome level. Then you can find the chromosome start and end by the Dropbox C chart here. The next panel is LR spectrum, which will be shown immediately after the SNP data is loaded. In this panel, you could only see the case samples, with their sample ID listed at the left side, and chromosomes are listed at the top. Genders are annotated at the right side, with the pink for female and the sky blue for male. In LR spectrum panel, light gray color shows the LR around 0, which means the copy number is 2 for diploid organism. Here is human. Red means the LR is bigger than 0, indicating potential copy number gains. Blue shows LR is less than 0, which means potential copy number losses. The color is also scaled to show different copy numbers. For example, dark blue means 0 copy, while light blue means 1 copy. For example, on Y chromosome, you could see female with a dark blue and a male with a light blue. From the LRR spectrum panel, you could have an overview of the whole chromosome CNVs. And also, you could check specific chromosomes, genes, or genomic regions. For example, if you input a chromosome 12, the calculation will be done for all the chromosomes once and for all, and then show you the LRR on chromosome 12. You can zoom in to any region with a mouse swipe. And zoom out with the buttons here. And also you can input a gene's name, for example, tumor suppressor gene CDKN2A. You can see the gene region is marked in green bar. And you can see this gene is observed with 0 copy in some of the cases. To view specific genomic region, you could input the coordinates like this. And it will be shown just like a gene. If the input couldn't be recognized correctly, then the whole genome spectrum will be shown. This spectrum view is very useful to check if a specific gene is affected by CNV across a group of samples. So far, I have introduced the most functions of ShinyCNV app. When you finish, just close the app. Then, copy the annotation from CNV.back to your supplementary table. Thanks for watching this video. Any questions and feedbacks are very welcome.